Are you trying to study physiology and feeling lost? In Unraveling Human Physiology, I will try to make physiology easier for you to understand.
In this video, we are going to talk about the difference between strong acid and weak acid, and also between strong bases and weak bases.
If you combine two molecules of water, you will obtain hydrogen and oxidryl. So, in a way, it's like water is acting like a base and hydrogen as its conjugate acid. Interestingly, hydrogen doesn't stay in the same molecule of water but change partners many times per second, giving the impression that hydrogen travels. That gives the solution the property of conductivity. Here's another key point. Remember that the concentration of hydrogen and oxidryl are related. If pH lowers, that is, the concentration of hydrogen rises, then the concentration of oxidryl will lower. On the other hand, if pH rises, that is, the concentration of hydrogen lowers, then the concentration of oxidryl will rise. If we talk about pH, we have to mention acid and bases. So let's start with the acids. What happens if we add acid to water? If you add acid to water, you will obtain hydrogen and the conjugate base of the acid. That will, of course, raise hydrogen concentration and will lower pH. That's why we call acids proton donors. Acid can be weak or strong depending on the magnitude of acid molecules that will dissociate in water. An example of weak acid is carbonic acid. Carbonic acid will dissociate in water to form hydrogen and bicarbonate. How do we know it's weak? We calculate the acid dissociation constant of this reaction. The acid dissociation constant of this reaction is the concentration of hydrogen times the concentration of bicarbonate divided by the concentration of carbonic acid. In this case, it's very small, 4.4 times 10 to minus 7. Again, as in pH, we will transform the acid dissociation constant to pKa, applying minus the logarithm of the acid dissociation constant. For example, in this case, if acid dissociation constant is 4.4 times 10 to minus 7, pKa will be 6.4. We know that an acid is weak if the pKa is between minus 2 to 12. An example of a strong acid is hydrochloric acid. Hydrochloric acid will dissociate in water to form hydrogen and chloride. The acid dissociation constant of this reaction is the concentration of hydrogen times the concentration of chloride divided the concentration of hydrochloric acid. As hydrochloric acid is a strong acid, almost all the molecules of hydrochloric acid in water will be dissociated. Then the concentration of hydrochloric acid will be very small. If we divide by a small number, then the acid dissociation constant will be big. In this case, it's 1.3 times 10 to 6. We will apply minus the logarithm of acid dissociation constant to have pKa. pKa of this reaction is minus 6.1. You see a very small number. We said that if the pKa of the acid dissociation constant is less than minus 2, the acid is strong. And what about the bases? If you add water to a base, you will obtain the conjugate acid of the base and oxidryl. That will raise the concentration of oxidryl. But remember, if the concentration of oxidryl rises, the concentration of hydrogen will drop. If the concentration of hydrogen drops, pH will rise. And that's why we call the bases proton acceptors. Base can be also weak or strong depending on the magnitude of the molecules that will be dissociated in water. We have weak bases where only a fraction of the bases will be dissociated in water, and we have strong bases where almost all the base will be dissociated in water. As with the acids, we can analyze if the base is strong or weak, calculating the dissociation constant. But in the case of the bases, we call that the base dissociation constant. We also calculate minus the logarithm of the base dissociation constant, pKb. If pKb is between -2 and 12, we say that the base is weak. If pKb is less than -2, we say that the base is strong. So remember this key point. If the pKa of an acid is less than -2, we say that the acid is strong. If the pKa of an acid is between -2 and 12, we said that the acid is weak.
If you like this video, please give me a like, subscribe to my channel, and activate your notification to know when my next video will be on. Thanks, bye!